Okay, sometimes the problems get wordy. Let's read it very carefully. There's a lot of information hidden in here that is good to know. The derivative g prime of a function is continuous. Good to know that. Glad to know that. Otherwise, we might have some problems. And all zeros of g prime are shown in the table below. There will never be another zero for g prime out beyond the borders of what we see. They've listed them all. The domain of g is all real numbers. Okay, so it goes forever to the left and forever to the right. On what intervals is g increasing? What x value does g obtain a relative minimum? That's actually asking for a critical value of g, specifically the critical value that corresponds to a minimum. So here's what I'm going to do. I'm going to do this a little bit differently than I had done when I had worked through this beforehand. I made the problem myself. I'm going to draw a number line. And this number line is going to represent what I see. So at an x value of -2, at an x value of 2, and at an x value of 5, we have the same situation we had here on this one, or here on this one, where the derivative equals 0, only they're specifically telling us, they're representing it differently, they're telling us where the derivative equals 0. I don't have to plug anything into any equation. I have no equation, but what I do know is that on this interval, the function, not f, g, the function has a derivative that is positive. Now you could say, oh, but it's decreasing. It's going from 12 to 9. No. Yeah, but it's positive, okay? From here to here, the derivative is negative. Well, it goes -2, -1, -4, and I'm looking at what I'm looking. No. Is it positive? Is it negative? We're not going to play that game of is it going up, is it going down. Is the derivative positive or negative? Is the derivative positive or negative? The derivative is negative. The derivative is positive. How do you know you got them all? Because I've tried to write a parenthesis. How do you know you got them all? Because they said all zeros are shown in the table below. And also the continuity helps. The fact that we have continuity is a tremendous, I mean, we had to have it. We had to have continuity in order to be able to do this. So, let us proceed. I am looking for the intervals where the function is increasing. Let's go ahead and answer that. That's where the derivative is positive. So let's just write it. So g, not g prime, g is increasing. If this was a free response question, I would be really specific. I would say g is increasing on the interval from -infinity to, we're dealing with x values, here, -infinity to -2, and also the interval, technically, or also the interval from 5 to infinity. And I'm going to be really specific because I want to train you to write things and articulate your thinking. How do you know this is where g is increasing? Because I said so. Because g prime is positive on these intervals. They didn't ask you to explain your thinking, but it's a good idea to do so if you have the time, and we have time. So at what x value does g obtain a relative minimum? Okay, we have transitioned from increasing to decreasing, so just in case you care, and you should, this is a maximum. We transition from decreasing to decreasing. This is not max, it's not minimum, it's neither if you pronounce it differently than me. And this transitions from decreasing to increasing. This is our minimum. So here we go. That answers the first part of the question. This is going to answer the second part of the question. G of x obtains a relative minimum. It's okay to abbreviate that word. People know what it means. Relative min at x equals 5. The lights just automatically shut down, which means I should finish this video like right now. About to. And let's explain why. They didn't ask, but let's explain why. If this was free response, we would have to do so. Because g prime of x transitioned from negative to positive.
And I'm going to continue to be specific at x equals 5. And if you leave that last little part out, at x equals 5, I don't think it's a huge deal. Okay, I'm going to stop the video and turn the lights on.